Greetings to all of you. In today's session, we are going to start with the intermediate chemistry, which will be helpful for the international entrance and competitive exams as well. And if you are preparing for national level JEE Advanced and JEE Mains examination for IIT and NIT entrance exams, in addition, NEET Chemistry for the entrance towards medical examination and Telangana, Andhra Pradesh EAMCET exam for engineering stream. In addition to all these, if you are preparing for any government examination, this kind of session will be very much helpful. Let's enter into our today's session. Name the following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. As per this one, organic compound, we need to assign the name. IUPAC is the kind of organization which will provide the rules and regulation in order to assign the naming for organic compounds, right? So here is the cyclic compound which is having ketone, aldehyde and carboxylic acid. There is an ambiguity in order to assign name for the given compound because these many are present where we have to start numbering. That there is an ambiguity. In order to avoid, there is a certain protocols. According to that, the right naming will be 2-formyl 4-oxo cyclohexane carboxylic acid. This will be the right naming for the given organic compound. Let's see how can we name this compound. Right, this is considered as a special case, and where you can find a different this chain numbering will be having carbon of carboxylic acid, where carboxylic acid carbon can be taken into the numbering. So its numbering is also taken into account, and the suffix carboxylic acid can be mentioned. Okay, so 2-formyl 4-oxo cyclohexane carboxylic acid is the right representation, where formyl stands for aldehyde. Okay, aldehyde present on the second position. So obviously numbering will be started at the carboxylic acid, and formyl denotes this what aldehydic functional group. Fine. It is the aldehyde, and this carbon cannot be the taken into the chain numbering system. Fine. So here, if you see these many functional groups, always remember highly oxidized carbon is taken as the priority number 1. So that carboxylic acid, where carboxylic acid is there, that carbon resided with the number 1 position. Later on, second carbon which is accompanied by the formyl, and third carbon, fourth carbon we have ketone. If only ketone is there, on as taken as the suffix, but ketone is present as the substituent, so that we have to assign it oxo, where it is located on the 4th position. Second position we have aldehyde, which taken as the formyl, and 4th position we have oxo, so that mention 2-formyl 4-oxo, and elsewhere will be cyclohexane. This is taken as the cyclohexane, and the main compound is taken as the carboxylic acid. This is the way we can assign name in the special case where different multiple functional groups are present in the given compound. IUPAC suggested this is the right name for the system. For question number 1, B will be the correct answer. Move on to question number 2. Question number 2, which equation represents the reaction that takes place in a fuel cell? Fuel cell is the kind of system where a chemical reaction carried by the continuous supply of the fuel can be transformed into the electrical energy, right? So fuel energy got converted into the electrical energy, that is said to be a fuel cell. As long as we are supplying the fuel, and what electrical energy generation will be possible, that is the principle involved in a fuel cell. So many kind of systems will be there in general. Fuel cells will be used in the rocket launching and rocket traveling, like that. Space agencies we can use in general. So for that purpose, so in order to take the what we can say energy device in a space, especially they should be light in weight. That's the reason why gaseous components most generally used in the fuel cells. If you see, hydrogen is the lightest gas, and oxygen is also the gas you can observe, so that here the formation of water, there is no pollution even. So, and moreover, this water generated can be treated as a drinking water, so that it is more obvious and more suitable kind of thing to add to this fuel cell. Hydrogen oxygen gives rise to water. This is the example for the fuel cell given by Cambridge Assessment International Education. And this is the kind of what instrumentation for the hydrogen oxygen fuel cell, where hydrogen gas is taken over here, that is considered as an anode, and oxygen will be taken as a cathodic region. Hydrogen can liberate the electrons, oxygen being it is more electronegative comparatively as per the Mulliken scale. Oxygen will accept the electrons and convert it into oxide, and finally they get combined to give water with the liberation of electrical energy. And more efficiency you can observe with the hydrogen oxygen fuel cell, being these are gases, more penetration, more reactivity, and more electrical energy will be generated from this kind of fuel cell, right? So by that we completed question number 2. For question number 2, option number B will be the correct answer. Move on to question number 3. Question number 3 is collected from JEE Advanced Examination question paper 2022, right? 5 grams of sodium hydroxide is dissolved in water to get 450 ml of solution. What volume of the solution is required to prepare 500 ml of 0.1 molar sodium hydroxide solution? Fine. So what they are giving, weight of sodium hydroxide is given, and this amount of sodium hydroxide dissolved in 450 ml of solution means M1 V1 are known to you, and M2 V2. So here the formula required will be M1 V1 is equal to M2 V2. M1 is known as a 5 grams, V1 is known as a 450 ml, V2. What volume of solution required to prepare 500 ml of 0.1 molar NaOH solution? Okay, so in order to get the solution, what will be the volume of solution required from this one, from this stock solution, right? So for that purpose, we will use M1 V1 is equal to M2 V2 formula, and very simple calculation it will be, and we can say it is the problem given from chemical equilibrium session. And let's solve this one. Molarity of sodium hydroxide. First of all, let's calculate molarity. 5 grams and 450 ml is given, so that weight by gram molecular weight into 1000 by V in ml is the molarity formula. In general, we can use in order to deduce the molarity. Molarity of sodium hydroxide is calculated as 5 by 18 molar solution. Then let V volume of solution is required to prepare 500 ml of 0.1 molar NaOH. Hence, V into 5 by 18 is equal to 500 into 0.5. Just now we said M1 V1 is equal to M2 V2 formula we have to utilize. M1 is nothing but molarity of sodium hydroxide what we got, that is 5 by 18. 5 by 18 you can directly put over here, and volume. So V ml of solution you are preparing, that we need to calculate. So that is required actually. What extent solution you are preparing? 500 ml. That 500 ml solution we require, so that it is taken as V2. And what should be the molarity of that 500 ml of NaOH? 0.1 molar is required, so that we can put V into 5 by 18 is equal to 500 into 0.1. So if you cancel out all the known terms, so that volume of NaOH required in order to prepare this solution will be 180 ml. So this is simply calculated by taking known values to unknown, moving from known to unknown. So this is the question given from the chemical equilibrium. So for question number 3, option correct answer will be 180 ml of sodium hydroxide required in order to prepare 500 ml of 0.1 molar NaOH. Simple steps involved in this. Initially, whatever NaOH is given, that can be calculated for its molarity. Later on, we have to use the formula M1 V1 is equal to M2 V2. Simply, you can put all the known terms and we will get the volume of NaOH. Move on to question number 4. This is also from JEE Advanced question paper, and match the following problem is given to you, and it is the part given from metallurgy. Metallurgy stands for what? Any crude material, mineral, ores located inside the earth. They got extracted, they get refined, and so many steps involved in that. Finally, pure metal got extracted. The entire process is said to be a metallurgy. Okay, so some kind of metals are given, their corresponding what extraction process they are asking for. Okay, what kind of so as already we aware that any metal we are going to extract, we need to heat at higher temperature, because metals can't be treated at normal temperature. We can't melt them, right? That's the reason why a special kind of heating devices are required, special kind of extraction process is required. Those process and what is the corresponding metal we are obtaining, this kind of mapping we need to go for, right? So in the question number 4, column 1 purely metals, column 2 what process we are opting in order to extract them. Aluminium metal, iron metal, silicon and copper are provided in the column 1. Electrolysis, reverberatory furnace, blast furnace, zone refining are the column number 2 terminology. Fine. Let's see how can we extract, what will be the right order. So there is the order provided to you. We will see in detail about this one. Right? Aluminium can be extracted by the process called electrolysis. Always remember, electrolysis will be applied for the metals of high reactivity. Any metal of high reactivity, we will go for electrolysis. Example, aluminium, fluorine also collected by this electrolysis, magnesium also collected by the same process. Right? Iron in general extracted by the furnace called blast furnace. Silicon extraction, we will go for zone refining method. Copper can be extracted by reverberatory furnace. Okay, this is the way, these are the suitable methods for the extraction of various metals by metallurgical process, right? So this is the one you can clearly see where this entire device, you can see two electrodes are located, positive and negative, and this is the process called electrolysis. For the extraction of aluminium, common ore we are taking is bauxite, and this bauxite will be taken inside some rods will be there, and positive terminal and negative terminal are connected to the external electricity, so that pure metal will be collected at the cathode and in the pure form. So this aluminium, being it is a lightweight metal, can find wide range of industrial applications and various applications in the aviation sector also we can use. So this is about aluminium extraction, and second is about metal called what? Iron. Iron is the kind of metal which can be found in the form of hematite, magnesite, limonite. So many kind of minerals are available, and it can be extracted by the process called blast furnace. Right? This is the way you can clearly see the device called blast furnace, and entire process will be described over here. Finally, we will obtain iron as the output. That pure iron can be collected in the blast furnace. Iron can be extracted by the device called a blast furnace. Move on to what? Silicon. Silicon can be extracted by the process called zone refining. Zone refining stands for what? So within the device, we are providing certain kind of the cylindrical one. So in particular zone here, heating coil will be located. So by using this one, so zonation of the system is possible. Silicon will be located in one region, and all the remaining impurities can be collected elsewhere. So this is the way we can zone refining method by using heating coil. So such kind of heating coil is used in order to go for zone refining. Zone refining is nothing but different zonations are possible. Refining stands for purification, and different zonations, impurities are collected at another end, pure compound, pure crystallized form. Here you can clearly observe purification by the crystallization. Crystallized form of silicon will be obtained at in another region. Okay, so this is the way we can clearly observe silicon can be extracted in the pure crystalline form by zone refining method. And this is called reverberatory furnace. Reverberatory furnace is more suitable for the extraction of copper metal from the whatever the kind of starting material. It might be copper pyrites, you may take any kind of raw material, raw mineral we can take, and reverberatory furnace is suitable for the extraction of copper metal. So extracted metal can be represented. The main content involved in this will be whatever the device we are using, in all the cases we need to provide the suitable heating condition, then only the exact extraction of that particular metal is possible. Let's sum up all the things. Aluminium can be extracted by the process called electrolysis. Iron can be taken by blast furnace. Silicon extracted by zone refining method. all are metals only except silicon, no, so that we are not using that extent of higher heating conditions, so that it is somewhat different. Zone refining we can add. Copper is the metal, so that we will go with the reverberatory furnace. Furnaces, electrolysis, all these are higher temperature devices, can be suitable for metals. Silicon being it is the semiconducting metal, we can say metalloid in clear sense. We can go for what? Zone refining. So this is the way question number 4 can be answered. For question number 4, option number A will be the right answer. Let's move on to question number 5. This is collected from the Gurukulam entrance examination for junior college lecturer. And the common coordination number of A block elements are present in the periodic table, where incoming electron enters into anti-penultimate shell n-2 f orbital, got filled with the electrons. So F block elements, what will be the coordination number? What is meant by coordination number? Coordination number stands for how many bonds are present around the central metal, how many set of ligands are occupying around the central metal is called its coordination number. F block elements are larger in the size. That's the reason why they can accommodate more number of ligands around them. So there is a possibility of around 8 or 9 ligands around the A block metal. Hence they can find a larger extent of coordination number. Okay, coordination number mainly depends upon the size of the metal. Tiniest metal can accompanied by the less number of ligands, but A block metals are larger in size. That's why they can accommodate more number of ligands around them. Fine. So let's see how can we explain. If the coordination number is 8, this is the possibility. This coordination number is relatively common for larger metals. In order to get coordination number 8, metal must be larger in size. The simplest structure is cube. So you can clearly see cubic structure over here, which is rare because it does not minimize the interligand repulsive interactions. So rarely this kind of occupation is possible. This is the exceptional case, we can say. Common structures are the square antiprism. Square antiprism is commonly observed 8 coordination numbers, and dodecahedron is also possible, both of which can be generated from the cube. So cube actually possible for the coordination number 8, but in that cubic form they are not staying in the stable form. No, that's the reason why they will adopt some kind of modifications. What modifications they are adopting? Square antiprism or else dodecahedron. So square antiprism, dodecahedron are represented in this one. So this is for what? Coordination number 8. Move on to coordination number 9. 9 means what? 9 ligands are present around the central metal. Set of ligands are 9 and the central metal will be there. This coordination number is found in the larger metal, and the most common structure is tricapped trigonal prism. Tricapped trigonal. So it looks like a cap. Tricapped trigonal prism will be there. And the simplest example is neodymium H2O taken 9 plus 3. Mostly A block elements, a common oxidation state for the F block elements around the central metal will be plus 3. That is known to everyone, no? But the coordination number will be either 8 or else 9. Okay, so here if you observe, 9 water molecules are surrounded around the neodymium metal. Right, this is the way we can answer this question. For question number 5, option number 2 will be the correct answer. For F block elements, 8 and 9 coordination numbers are possible. Move on to question number 6. This will be the last question for the session. What is the anode and cathode used in the electrolytic refining of copper? Okay, so electrolytic refining just we saw for aluminium, no, and the same we are also applying for copper. So electrolytic refining means so copper, crude copper metal will be, ore of copper metal will be taken in the container. 2 electrodes will be inserted. One pure electrode, one impure electrode will be inserted, so that current will be passed over 2 electrodes. So a pure form of metal will be collected on one particular electrode. This entire process is said to be electrolytic refining. And what will be the kind of device? we are using in electrolytic refining of copper. Impure copper is taken as the anode and pure copper is the cathode. This will be the right arrangement for the refining, electrolytic refining of copper. Let's see how can we explain that. Electrolysis is the process where by applying the current, if purification or if extraction is possible, that is called electrolytic refining method. In general, anode will be taken as the impure metal, we can clearly see over here, and the cathode is taken with the pure metal. Pure metal is taken as the cathodic region, and electrolytic solution filled here is called copper sulfate. And from these electrodes, we are passing the current. Current is able to pass. Whenever current is passing, copper metal will be deposited on the cathodic metal. This is the way we can extract the metallic copper by electrolytic refining. By this, question number 6, option number 2 is exactly justifiable. Impure copper taken as the anode and pure copper is regarded as a cathode. By this, we completed the session. So all 6 questions are clearly explained, and I think this will be helpful for your preparation if you are seriously preparing for any kind of entrance or competitive exams as well. So that I'm sincerely requesting you to like the channel, comment which part is really interesting and what part of things we need to discuss more, and share this channel with any other aspirants which are who are seriously preparing for the examinations, and subscribe the channel in order to get more such kind of updates. And thank you very much for your kind watching. Thanks one and all.